Now let's put all this new information to good use with a programming task. This one says, modify our old friend rock, paper, scissors to display the all-time high score when the game starts. And, if the player does better while they're playing, update that high score for the next time around. So in VS Code, I've made a copy of our old rock, paper, scissors game. This one has functions for all the different parts, and a main function for maintaining the game loop. Here we also have a score for the user, so that's the thing that we're going to be keeping track of. If that's better than some high score, that's the one we're going to want to store. In general, in order to store the all-time high score, which is to say the high score over multiple successive runs of our game, we're going to have to store that high score in a file so it persists between games. So we can make some simple text file. We can call that highscore.txt. And since we don't have a high score, we'll store some default value 0, some default score here. Okay, that's line 1, and this file only contains the value 0. Might be a bit misleading in this display. Then back in rock, paper, scissors, what we need to do is access that file so we can read the high score, so we can present it at the beginning of our game. So somewhere here before the game starts, we want to present what the existing high score is. Then we'll let the user play the game as they normally would. But when they're done, they have a new score. If that new score is better, that is, say, if it's higher than the previous high score, then we'll replace what exists there with this new score. So we'll say something up here along the lines of present the high score to the user. And down here we'll say check if there's a new high score. Now these two operations, this first one involves reading from our file, and this second one might potentially involve writing to our file. But in the main method, we're not going to worry about those lower level details. This main method, remember, is to organize or orchestrate the top level of our game. So let's use a function call to do these things. So we'll say the current high score is equal to get high score. Now this is a function that doesn't exist. So our linter says there's a problem with that. Syntactically correct, but that function is not defined. So we're probably going to get a problem. So what we can do to get around that warning is to create what's known as a function stub. So I can say def get high score, and then instead of putting any actual code in there for now, I'll just say pass. So pass means do nothing. It's if Python encounters this line, it'll just go on to the next line. The reason we put that in there is because if we don't include it, then the function is an error because it has no function body. So by putting pass in there, it's a way of saying do nothing, but intentionally do nothing for now. Later on, we'll come back to this line and we'll fill this in with the details for actually getting the high score. But assuming we have some function that magically works, when we call get high score, what we get back should be the value of the high score. We'll figure out how to make that magic work, but assuming that's in place, we can continue on with the high-level description of our game. So if we have the high score, we can just print that to the user. So print the current high score is... and then print out the value of that high score. Then we enter our game loop, that plays the game, and we come down to the end. At the end, we have to say, did the user's score beat the high score? And if so, we need to store it. So we have the user's score here. We can check if it's better than the high score because we have our high score variable and our user score variable. So we can say if our current score is better than the current high score, space for clarity. In that case, we'll say, let the user know that they beat the high score. So a new high score, exclamations, what an exciting moment. And then to make sure that this stays for the next time we play the game, we can say set high score to being the user's score. Again, this is a function that doesn't exist, so we can make a stub for it. So I come up to the top here, I say def, I call it set high score, and that takes in some value score. But for now, again, it doesn't do anything. So looking at our top level main function here, we're going to get the high score somehow. If we have that, we'll print it out, we'll play the game. At the end of that, we'll check if the user score beat the existing high score. And if it did, we'll print out congratulations, and we'll make sure that gets updated into the file. Okay, so now we need to make these functions for getting and setting the high score. So let's start with the getHighScore function. So remove the keyword pass because now we're not going to pass, we're going to actually do something here. So the highscore file is a file that already exists. It's called highscore.txt, and it's in the same directory as the rock, paper, scissors game that we're looking at. So all we need to do is say, open that file, read the value from that file. Again, the file only has a single number in it to keep our code simple here. Read the value of that file, close the file, and make sure we're turning the score. Noting that here we're converting the score to a string, so it's probably not already a string. And down here, we're assuming that score is something that can be compared to a number, so it should be a number. So we'll return the high score as a number, even though we're reading it as a string. So step one is to open the file. So I'll say file equals open, and then the name of my file. So I'll just say highscore.txt. Now in this case, I'm reading from the file, so to be explicit, I'll include the read mode argument as well. Now, there's only one thing to read from that file, so we can read all of it or just a line and it does the same thing. So to simplify the number of characters we have to type, we can just say file.read, which gives us the entire file as one big string, which again, since there's only one number, is just going to be that one number as a string. And we need to store that in our code, so we'll say score equals file.read. At this point, score is the string of whatever number is stored in that file. And there might also be some white space in there. So one thing we can do is convert that into an integer, but also let's make sure before we do that, that there's no white space around that integer. So we'll say score equals, we'll take the string that we've read, so score, we'll say dot strip to get rid of any white space that's around that. So if there's a new line in there, we don't have to worry about that. And then we'll take the whole thing and convert it to an integer. So we'll say int of all of that. At that point, we've read all the information we need. We can actually close our file. Actually, we can do that on the line above. So we can say file.close, since we're no longer reading from the file. And then we can do all our processing. And at that point, we're done getting our information. We have the information in the format we need, so we can just return it. So we can say return score. Okay. Now there's a few assumptions in this function. The first is that that file exists, because if this doesn't exist, then our code will crash. And the second is that that file contains only a single integer, right? So if I strip away all the white space, there should only be an integer remaining in that file. If it doesn't, then when we try to convert all of the text into an integer, then our code will crash. But if we assume the file exists and it has a number in it, this should be fine. Let's test this out before we build the second half of our program. So we'll save, say python rps.py. And it starts up and it says the current high score is 0. So that's great. It read the high score. And if I play a bit of rock, paper, scissors, my current score is -1. So that's maybe not great. Trusty old rock is failing me. Anyways, we'll stop. Our final score is -1. Everything worked more or less as expected. Returning to our code, we've got the high score. It displayed what was in there, which was just the number 0. So not super exciting. But once we have the next part of our code, setting the high score, then we can have a whole circuit where it sets a new high score and we can read it in the subsequent uses. So the next step is to write the setHighScore function. So we'll get rid of this word pass, and in its place we'll put some actual code. So the steps here are to open the file, write to the file, and close the file. So opening the file is as before, we say file equals open. So our file is still called highscore.txt, but this time we're opening in write mode. Notice we don't want append mode because there's only going to be one high score. So we want to destroy the score that's there and put a new one in. If it doesn't exist, then we'll make it. That's fine. Okay, so we've opened the file. Next is we want to write to the file. So we're given this variable scr, which contains the user's current score. So we'll write that to the file. So we'll just say file.write, remembering that the thing we have to write is a string. So we'll say str of scr, so the string of our input variable. And when that's done, we can just close the file, file.close. Awesome. Now testing this might be difficult because we have to get a high score bigger than 0, but I believe in trusty old rock, so let's test it out. Current high score is 0 still, makes sense. So if I try rock, my score is 1. All right, quit while I'm ahead. So we'll say stop. And we got a new high score. So it told us that. We got a new high score. And now when we run our code a second time, it knows that the previous high score was 1. and then we can play our game again. So the information from one execution of our code persisted into the next execution. You can close VS Code, you can turn off your whole computer, and when you come back, that file will still have that new information. So the updated high score will persist for as long as you need it to, until that file gets somehow destroyed. Now, one thing I'd like to point out is here we're accessing the file by its name here, highscore.txt, and we're doing that in two different places. So it's a good idea, I'm just going to scroll to the very top of our code here. This is a good use case for a global constant. So if I have a specific file name that's always going to be used, it's possible later on I might decide to change the structure of my code. Maybe I need to move that high score file into some subdirectory. If I do that, then I'm going to have to find all the places in my code where I've referenced that file by its exact name and change it to the new exact name, and I'll have to change it every time I've used it. However, if I use a global constant, I'll say high score file name equals highscore.txt. So this is a global constant because it's not declared inside of any of our functions. And now everywhere we want to reference this highscore.txt, we should just say highscore file name instead. So coming down to our two functions here, we have file.open here. We'll pass in a file name, and here as well. Notice this is not defined locally. It's not passed in as a parameter. It's a global variable. And since we didn't use the global keyword, this is a global constant. Now what this does is it puts the file name in one place. So if we refactor our game, let's say maybe I put this into data instead. Now all I have to do is change it here. I can just say /data, and I didn't have to change it everywhere. Now everywhere that's referencing this location via this file name will reference the correct location. Write once, use many times. So if I stop and run our code again, it works just as well because we've updated the location. One more thing to say about file I/O in Python is that in all the demos so far, I've been careful to close the file after I've opened it. In Python, if we don't close a file, then Python will close it for us when we leave the current function. So this is a nice safety feature. It protects us from leaving files sitting open when our code ends. And although Python offers this design security, other languages you will use might not. So it's a good idea to get in the habit of always ensuring that your files are closed when you're done using them. You might think it doesn't do anything, but it looks cool, which is kind of true. Some of its utility is in that it's visible. You can see the extent in your code of that file lock. So when you open a file, you're accessing that file, but Python's also holding on to that file because it needs to either write to or read from that file. If we have an explicit file.close statement, that makes it visible in our code that after that point, that file lock is non-existent. And just by glancing at the program, I can consider that this resource is in use for that section of the code. And outside of that section, it's not. Also, because we can see the extent of this context window, as it's called, then we're able to minimize the extent that we're using that resource. That is, we can ensure that the file is only open for as long as it's actually needed, which becomes significant when you consider that your programs might become quite complex, with many separate processes all vying for the same shared resources. At which point having very strict controls over who's accessing which file at which time can become quite important. To that end, Python 3 added the with statement, which similarly makes the file context visible in your code by indenting the section where it's used. Generally speaking, using the with statement is the accepted way to do file I/O in Python, which is to say we don't tend to see a lot of file.close operations because with replaces them. The purpose of the with statement is to manage some context. So we're going to apply it to files here, but it does apply more broadly in Python. When you're using a with statement, it manages the file context window into an indented statement body, and it will automatically close your files when you exit that context. The syntax for a with statement is with some expression as some target, so that's a variable name, and then we just do whatever we want within that context. So to open a file, for example, we'd say the keyword with, and then the open function, as we've done before, where we pass in the name of our file and optionally the read and write modes. So say with open some file as, and then the name of our variable. And then in the body of that with statement, we say the name of the variable dot read lines, or whatever we were doing already with those files. But importantly, once this with statement ends, that is to say once we reach the end of the indented code underneath it, then the file that was opened closes automatically. The context of that file ends with the end of the with statement. So returning to our rock, paper, scissors example, For setting the high score, for example, we could, instead of doing these lines, just take all of this and comment it out. Instead of doing these lines, we could say instead with open high score file, file name, in write mode as, and I'll just use the same name, file. And then we do the same steps. So we'd say file.write whatever we want to write, and then we're done. Notice we don't have to close anything here because as soon as we exit this, so if we had something like print all done, as soon as we got to this print statement, we're outside of the with statement. The file link we created, which we just called file here, is then closed. So continuing on with the next line in a context that doesn't have that file. So we don't need that part, but just to demonstrate. We could say the same for reading the file as well. So all of this code here is to open, read, and then close the file. So I can comment that out and instead say with, same thing, open high score file name. In this case in read mode, which we can leave off if we want, and we call this one file as well. And the next line just says score equals file.read. So we process that file the same way we would before, so file.read, but then afterwards that file closes itself. So the only thing we need to do with the file open is read from it. All the stripping and converting can happen afterward once we're outside of that context. So the only line we need to put into that with statement is just the read. Now we have two single line with statements, so I should emphasize that you can have more than a single statement inside your with statement. You can have a loop that reads through line by line, for example, if you wanted. The with statement, like any statement that contains a body, can have multiple statements within that body. So let's save and make sure we didn't break anything. Running our game again. It still knows the current high score is 1. We can try to beat that. Oh, we're already off to a bad start. There we go. Good old trusty rock wins every time. Let's stop while we're ahead. We got a new high score, and if we run our code, that high score stayed. So we could play again. Some sort of paper, rock. There we go. And if we stop, thanks for playing. We didn't beat our high score, but game still run to completion. All right, so that's file IO in Python. So very simple syntax: open the file name, read mode, write mode, append mode. The file.write function for actually writing things. And we saw the with keyword for creating a limited context for accessing those files.